This is IGCSE Chemistry, and today we'll be working on chemical bonding, starting with an ionic bond. Ionic bonds exist between metals from the left-hand side of the periodic table and non-metals, where the metal ions lose an electron to form a positive ion and the non-metal ions gain an electron to form a negative ion. An electrostatic attraction exists between both ions to form the ionic bond. The ions cluster together to form an ionic lattice. Electrostatic attractions form between the ions. This makes ionic compounds have a very high melting point. Ionic compounds are brittle. When you apply a force, you'll find the layers slide past each other, and ions of the same charge come in contact and they repel, causing the breaking of the ionic lattice. We will now move to covalent bonding. A covalent bond forms when two nonmetal atoms share a pair of electrons. The positive nuclei of these atoms attract to the negative electrons to form electrostatic attractions. Despite the strong covalent bonds, covalent molecules tend to have weak intermolecular forces of attraction. Those intermolecular forces are easy to break, and that explains why many covalent molecules exist as gases at room temperature. Unlike simple covalent molecules, giant covalent structures like diamond have very high melting point because of strong covalent bonds that exist in this giant lattice. The last type of bonding that is required for IGCSE is metallic bonding. Metallic bond is described as cations that are floating in a sea of mobile electrons. Those positive cations attract by electrostatic attractions to the sea of mobile electrons. Metals are known to be good conductors of electricity because the mobile electrons can move in one direction when a voltage is applied. Unlike ionic compounds, metals are malleable. When a force is applied, the metal changes its shape because the cation layers can slide past each other.